In previous videos we've shown you how to build scenarios from scratch, how to load them. For example, here I will load the contingency plan network into the user interface, and how to run the scenarios by running simulations. So I'm starting a simulation here. Alright, let's stop it and reset that. However, what I haven't shown you yet, and I'd like to show you now, is how to use two other APIs for accessing this. One of them we have on the left here is the console. If we minimize the panels at the top here, we have access to a console at the bottom here. And this console has a number of commands that you can type. You can, for example, type occur to make the simulation run one step. You see it happened on the right, one step fired. You can also type occur maybe 4 if you wanted to run 4 steps. Boom. Ran 4 steps in a row. You can see already that this service stopped problem has now moved after the network access check. If I occur once more, it will repair the server and leave the token up there. So let's do one occur. Boom, there it is. It's back up there and it's now fixed. And the previous one was already fixed by the occur 4. You can also change to the time simulation with the simtime command. Now, if I do occur 1, it will actually step 1 second. We see that did not change anything because there were no transitions ready to fire in that second. If I do another second, so I have to do a few seconds before it will actually do anything. I think it will occur at 5 seconds. We're nearly there. One more. Boom! You see quite a few things happened. I could of course occur at 100 seconds and finish the entire simulation. Wow, there we go. And we get the report as well. If we reload, we get back to the beginning. If I occur 100, we go to the end. We can also reset. And the reset is similar to reload, except the reset will take what's currently in memory and set it to its initial state, whereas a reload will reload it from disk. This sounds like it should be the same thing, but let me show you the help here again. There is an interesting command here called model, which you can change the in-memory model with, and then a reset will reset to the initial state but maintaining your changes, whereas a reload will revert to the on-disk version. So that is a difference. So help command can also give you help on each command. So I can say help model, tell me a little bit about this. It says send a command to the current model. In brackets, all DSL commands are supported. For example, model, threat, failures, problem recovery, repair it. Okay, this model command, I'm going to now pass the threat command. In fact, for the syntax of the threat command, it's giving you some help here. But you can also get help by looking at the original DSL script that you used to build your model. Let's have a look here. I can see at the top here, I have a threat on the failures vulnerability. I have put a threat called network off, and I've said it's ready at 1. Now, inside the DSL, threat is a method with a comma-separated list of parameters, and since it's Ruby, this over here becomes a special map of key value pairs, and you can pass other maps at the end here. This syntax is not going to be valid on the command line, so we've made a slight change to it. You'll see instead that it's a space separated. There's a space, there's a space, there's a space, and the map is now string colon string, comma string colon string, with no white spaces except quote separated white spaces. So I can say failures. Let's put a quote here and say something bad happened. So that's the actual threat. And now I need to pass it a map. If I don't put the recovery option there, unlike in the DSL, I need to show you that in the DSL again here, this threat is not processed until the end of the contingency plan. Let's have a look down here. After the contingency plan, this end statement here, these repairs are matched to the threat, and we can see here that these repairs have been tied to threats, and that tie-up is an important correlation to make. So we get a load time check. However, we're going to be putting a new threat statement. Instead of it being at the beginning of the file, we're going to be shoving it at the end now, down here. If we do that, it's going to check immediately and not find a repair matching that threat. So we will get an error. We can avoid that error by defining the tie to the repair at the same time as the threat. And the syntax for that, I'll show it in the DSL, would be threat. Oh, sorry, it was failures, right? That was the thing. Now let's be polite. I can do it over here. Recovery should be the repair server. That's our fallback recovery, the expensive one that takes a long time. If we don't know how to fix it, we repair the entire server. So this statement will work. It's going to create the threat and check the recovery and then double check everything else up there. So let's, we're not going to reload, we're going to put this exact thing into the console instead. Something bad happened, recovery, so the syntax here is slightly different, colon, repair server. There we go. Now you'll notice that we have up here something bad happened. We've got 4 tokens in here instead of 3. We've added a new one. And repair server is repeated twice. And down here in the repair server, we see we have the server stopped and something bad happened as threats known to this server. And this failure, I think that's written over this. We need to move it up slightly. If we had not set that recovery, let's make another one. And we don't put the recovery, you'll see what happens. Failed to process the DSL command, help me please, is invalid. No recovery is defined. So we were not able to do it, we couldn't add it. So we do need to specify the recovery. This is the difference between this and the way it works in the DSL, the actual file, because the file can wait until the end of the load to process these correlation statements, whereas here, once we've sent the command and we've completed an action, it needs to do the check immediately. So that's why we need to do that. Alright, now it has successfully added the help me please, because it was successfully connected to the right thing. So I said help me please should be repaired by the network repair. So I've decided to state that this is a network failure. And this will cause a runtime error because we know that our network repair will not know how to fix that. Actually no, our network repair in this particular model is all-encompassing. It just puts the word fixed on it, which will pass this test over here. So this particular contingency plan is perhaps slightly unrealistic, but it will work in this case. The next thing to show you here is how we can also add times to that. You'll notice that these 2 new ones don't have times. They haven't been told when to occur. If we define these tokens as threats, then they also are required to have unique names. So we can just simply redefine it by adding some time, say after 40 seconds, help me please, after 40 seconds, and it will modify. Let's move this out the way, and you can see there 40 has been added. Now something bad happens, still doesn't have one, so we just push the up arrow a few times till we get to something bad happened and say comma after 60. Notice I did not put a space in there. The space can occur within the quotes, but this entire last string from recovery all the way to 60 is one argument, and this is currently unnecessary. There we go. Command, let's put it in. Something bad happened. Alright, it will shuffle to the end of the list here. What it did is it pulled out, it deleted the old something bad happened and made a new one, this time with a 60-second. So we could in fact run this. Let's step through it. One, so we see these things are going ahead. Up, and it's finished. Help me please did not pass expected recovery. It went to repair server, and we said it should go to repair network. And if you look at the choice down here, let's move back here. It will go down, it will make the choice here based on the network. If the actual threat doesn't contain the word network in it, it's not seen as a network threat. So we can't say that it should be repaired by the network repair without either changing this token or telling it to be repaired by the server. So let's fix that as well. Where's the help me please should be repaired by the server. There we go. And let's reset it. If I did reload, I would lose these new tokens that I've added. Reset is required to get it back to the initial state and maintain my manual edits over here. Let's click through it. Or we can do it in the command console. Let's do occur 5. Another 5. Boom. Another 5. So notice that I'm occurring steps here, actual transitions, and look how far the time has gone. The time jumped forward so far because there was many big areas of time where nothing was happening, and that's because some of these threats were scheduled to happen after 50 seconds or 40 seconds after 60 seconds. We see the two we added, there are 40 and 60 seconds, so they will happen quite a lot further in time. So in this case, occurring by step is faster. There we go. Final report, everything passed. No failures, everything worked. So let's show you how we can do all of this from the REST API as well.